Hello everyone, welcome back. So today we will see an example of parallel processing in SAP. Now the reason or the why we use parallel processing is if we want to execute the same functionality multiple times and over different instances so that we can pass a set of data to the processing and then collect the data from there and then do whatever processing we need with it. So I'm just going to start with the calling program. So in our class we are going to call a class. So I'm just going to rename this as process parallel or parallel processes, if you will. Create. So it's going to be a local class. Okay, so let's just name it as process. We will keep this as static and public so that we can debug it. And now I'll just go inside of it. So let's say I'm just building a use case here. Let's say we are just for testing purposes selecting some data from a table. Mm, oh, now I'm just going to do a couple of rows only, up to 5 rows. Okay, not even 5 rows. I'm just going to do 3 rows because 3 instances will be generated then in that case. So if size versus initial, so this is our table for like service order headers. So we have a function module to read the service order data. So it's going to be the CRM order read, yeah, the first one. So just building our use cases here again. What we do is we will pass the goods in here, and then we will just import the header data of those goods. So I don't need any of this. So this is just an example, obviously, according to your requirements, your functionality that you would want to implement is going to be different. So in here, since this is a function module, you cannot really use the converting. So what I'll do is just do this. LT header good, type this, and we will import this. So let's say it is LT order ADMH type something. It will be from here, this one. And what we will pass is header grid. Now, so we have 3 records in this. If size versus initial, what we will do is we will loop at LT orders into data ls orders. And then I'm just going to end loop it here. And we will append ls orders go to this. Perfect. So everything is activated. And now just for testing purposes, I'm going to see if the data is coming up all right for this one. If size is equal to 0, I'm also going to be clearing all the variables. So clear your input table, your output table, and also your work area. So this is just good practice. Cool. So let's just debug this and see. We have 3 orders, and The syntax check. Okay, so we have that, and then we have second record also, and then we have third record also. So our data is perfect now. So this is just our data that we are going to see. So now that you see that we have records here, and then we are just, this is the piece of functionality that we want to process in parallel. Now it can be any functionality as per your project requirement. So we'll just see an example of how this is done. So to do parallel processing, what we were going to do is just to create a function module, an RFC function module, and that function module is going to be called in parallel process. So I've already created one here. So this is called as Y parallel process. So you need to create a function group also for this one. Once you create the function group and the function module, make sure in the attributes that it is an RFC function module like this. Click this radio button. And so the importing parameters for this function module are going to be what you are going to feed that function module. So in our case, it will be this one. So we'll just take this type and uh, write this as an importing parameter. Just make this ID. So it's only pass by value. So this is the pass by value. We need to make sure that this checkbox is ticked. This can reduce performance. It's fine. We cannot do anything about it. And then in exporting, what we'll do is the result of the function module. So it is going to be this one. So it will be ET. And this is your type. Now, again, pass by value flag. So keep in mind. Yeah. So you see those parameters here. So then what I'll do is I'll just copy this code. In fact, all of this one. And then paste it here. So this is going to be your input structure and this is going to be your output structure. If size of RC equal to 0, then what we'll do is just clear this one. Pretty printer. Oh, so now it's activated. So this is going to be your parallel process function module. Now, of course, you can have many different, you can call different methods from this class itself inside this, but then, yeah, that's a different example. Okay, cool. So now your function module is ready. So what you'll do is I'll just remove this and call my function module here. So this is that parallel processing. So what I'll do is just pass this importing and then I'm going to take this importing this. Okay, cool. So then now this is cleared, this is also cleared, and ls orders is also great. So now at this point, this is, even though it has an RFC function module, this does not really be fulfill the function of parallel processing. So to enable that, what you'll do is add some syntax here, like starting new task, and this should be your task name. Now, because you're going to start a multiple tasks, for example, in this case, this is going to loop 3 times. So then is going to start 3 different tasks. So this task ID should be unique. Is it in? No. So destination in group. So this can be destination in group, or you can even specify the destination server name. So you can just specify the server name here, whatever it is. Or you can do destination in group. We don't really suggest destination in the, hard coding the application server name in here, because in production, we really don't want to be limiting it to just one application server group. So we will do this destination in group. Now this group, you can find it out in the transaction RZ12. So in our case, our logon group is, for parallel processing, we have a separate one. So this is called parallel generators. So for now, I'm just going to hard code this value, but I'm sure you have some constant somewhere already created in your code base. So you can just use that one. So destination in group, parallel group. Now, so let's destination in task ABC. Nah, I'm just going to leave it like this. Um, calling call back on end of task. So this calling functionality, this is used for getting the data back from your calling function module. So I'll just put this at the end and then we will see how this is working without it. So starting this does not allow importing parameters. Yeah, okay. So that is my mistake. So in this, you're not supposed to be using your importing parameters from your function module. See, as soon as you removed it, it's gone. So you'll wonder if you're not able to use it from here, else are you going to collect the data? So that collection of the data is going to be used from here. It is call end on end of task. Now, if you go to this, it will say that, okay, this method is unknown or protected or private because we haven't created it yet. So we'll just go in and create the method. So go back and create that method. So I'm just going to make this as again static. You don't have to make this static. This is just for our demonstration purposes. Obviously, you're going to make it instance or private and public, obviously, according to your requirements. So now if I go here and then try to activate it, it says that the callback does not have the parameter p task. So this parameter p task is nothing but this task name that we assign. Now, the reason this needs a p task is because go to method definition. It's because when you're importing type p task, I'm going to do a string because when you are generating the three different instances of the parallel processes, all the three tasks they're going to come back to this, but they are going to come back to this one by one. So let's say the first task is I don't know, let's say one. Then when it comes back, it needs to go to callback number one. Then the second task will be number two. So it needs to go to callback number two. And then the same one, the third one. So for that, we need to have a unique task identifier. So what we will do is, let's say, when we go inside the loop, let's generate a task name also. Uh, oh, okay. Something called a generate task. Let's just do a. Okay. So this function module will automatically generate a task name for you. Mm, cool. So now because we have called this in a loop, it's going to be executed multiple times and it will generate a unique task name for us. And then what we will do is we will send this task name here, and then this task name is going to be sent inside this callback function module. We will test that out. Um, and then what another thing we need to do is when we are um, executing these parallel function modules, after all this loop and all is done, we need to sync the results. So I'm going to create another method called synchronize, or in fact, just write this here. Wait for asynchronous task until um, MV task is equal to 0. Now, what is this MV task? MV task is nothing but it's going to be a counter. So we also need a counter. Sorry, guys, this is not going into fixed or fixed defined steps. It's only going in the sequences how you are going to encounter it in real life. So it'll be counter type I. So we need this LV counter is equal to LV counter plus 1. And I'll, I'm not going to clear this because at the end of the loop, we want to see how many counters have been there. So the reason for this counters is now in, let's say this whole thing is running for 3 times for 3 different processes. So at the end of the 3 times, our counter is going to be 3. So the first time it's going to be 0 plus 1 is 1. So it's going to, at the end, it will be 3. So now when we come here, when we are waiting here, the task is MV, task is 3. So now this is MV. Let me just declare this first. I'm going to make this as instance and public type I. And then inside this callback function, what we will do is this, I'll come back to this LV counter in a bit. Before that, we need to go to the callback function module. Now, remember I said this callback function is for us to be able to receive the function, receive the results from this function module. So what we do is go back to this callback, and then inside the syntax is receive results from, then we write the function module name again, this one, receive results from 5 this importing. So this is where we write our importing this, and we need to also do the data declaration. I'm just going to go back in there and then copy it from there. So this one was the, we don't need it here, do we? Oh, okay. Don't need it here because we have moved it inside. So we need to also do this MV task. Save. So go back to call function, do this, and then do this. Okay, so now that we have that, receive results. So what's going to happen now is we will run the first process. The first process will run and give us the result here. The second process will come in and it will, find this P task that we have the unique identifier, and then it will come to this callback and it is going to give us this one. Now, because this is a local class, what we want is we are going to move it to append results of, like, you can do whatever you like, but what I'm going to do is append lines of LT order ADMH to, let's say, um, ST order ADMH. So now what I have done is I've created another global table here. So after all the 3 parallel processing have been completed, we will get a cumulative of all the results inside of this, because this is just the local. It's only there until that session is run. So that first session and second session and the third session. So all the data will be in this one. So I'm just going to go ahead and create another attribute. Um, ST order ADMH public, and this also, I'll just make this as static because everything is static, so I don't want any errors now. Okay, so activate both. Yeah, SV. So this statement now, wait for asynchronous task until SP task is 0. So what happens is now we have these counters. LV counter is 1, LV counter is 2, and LV counter is 3. So when we come here, what I'm going to do is I'll just assign this SV task as LV counter. So when we come after this end loop, when we come here, SV task is going to be 3. And what we are going to do is we are going to wait for these SV task until it is 0. which means that we are going to wait until all of these parallel tasks have been completed. Now, how do we know, how is it going to subtract this task from 3 to 0? So that subtraction is going to go into the callback routine. So once we receive the results and do our internal whatever we wanted to do, what we are going to do is do the SV task or SV counter. What was it? SV task is equal to SV task, sorry, SV task minus 1. So now what this means is like the first session went by, we have received the results for the first one. So in that case, the task was 1. So it will be 1 minus 1, 0. In the second time, it will be 2 minus 1, 1. So that means we are ensuring that all the tasks are completed. And when the task there is completed, that means the task becomes first 3 and then 2 and then 1 and then 0. So we are going to wait for all the tasks to become 0. And then what we are going to do is process. I'm just going to go again to the callback and st order admh. I'm just going to write this as an exporting parameter of this one. Et. So et equal to st. Cool. So okay, that's I'm hoping there's no mistakes in here when we are running. We'll find out soon. Just quickly taking you through the whole process again. So what we are going to do is we have in all of our data, whatever is going to be our input data. So we have that data and this parallel processing function module needs to be called in a loop. And inside this loop, we are going to um, create a unique task name. Let me also create this task name after every loop process. And then in our parallel processing function module, which is going to be our RFC function module, we will start a new task and in your destination group, which can be uh, an assigned dedicated group or any application server that you prefer. And then we will call this calling function module, like or the callback function, and we will collect all the data after the parallel processing is done. And then once all the processes is completed, we are going to display the data outside. Let's see how it looks in debug. So I'm just going to go ahead and put the breakpoint here. So you can see how how it looks like. Just put a breakpoint here and put a breakpoint here as well. So go to process. Now we have 3 orders like before, and we are at the first function module instance. So as soon as I press F6, it's going to generate a new session. So you saw this. This is your new session number 1, and this is your calling session. And your LV counter at this has become 1. So this was your first loop. Now again, second loop. So that has uh, generated a new session. So you see, this was the session number 1. This is session number 2. And I'm also going to do it the third time, which has generated the third session. So you have 3 debugger sessions open here, and this is the main one. So LV counter now is 3. Now we have come out of the loop, and SV task is also 3. So while we're waiting here, so this one is going to wait until SV task is 0. Now SV task at this point is 3, and it's going to be 0 when we execute all these 3 tasks. So this is your first. We have the GUIDs. We send it back into this ET order EDMH. So I forgot to put a breakpoint inside uh, the calling. Oh, this one is there. Okay, no worries. Cool. So the first session is gone. Oh, okay. Type conflict and callback. An attempt was made for P task. Oh, okay. So all of these sessions will go into dump. Illegal type. Oh, my bad. Let's me go in again. So the reason we got the dump was because the P task in this callback was of type string, but the P task or the task name in this case is this LV task name, so which is of type this. So that both of the task names should be of the same type. So just going back into callback, callback parameters. I'll change the type to this one. Cool. So now everything's activated. Okay, so I'm going to put a breakpoint here now because we've already seen how the three different sessions get called. Let's run it again. So yeah, running the process again. So this is your session number 1, and then session number 2, and this is your session number 3. And so now the task is going to wait for you to finish. So this is the asynchronous task, all these 3. So we'll do the first. We have some data. We're sending it outside in the function module. So now at this point, uh, we will do the second one, and then we will do the third one. And again, it's giving us incompatible to formal parameter p task. Why is that? Okay, so the type is not this. The type is type C like. So I just found it. So found this from Google. Yeah, but this is it. Yeah, so that's something we will have to remember that the task name is, it doesn't matter what task name you're sending it to this one, but the task name for your receiving callback function is type C like. So which is nothing but C like. What is C like? Oh, okay, so it's a predefined ABAP type. Cool, no worries. So we already have a breakpoint inside of this. So let's just execute it again. So we'll be doing the callback the 3 function modules now. So we've already seen how the parallel generators produces 3 different instances of those function modules because we had 3 records, so it generated the 3 different function module instances. And then on every instance is going to call this callback. So in this, what we are doing is receiving the results from this function module. So this is going to be the first one. Uh, it did not give us any result. Why is that? Mm, so let's debug. Just putting the breakpoint again. ET order EDMH. Okay, because if size of ours is 0, it shouldn't be is equal to, it should be if it's not equal to 0. That's the reason we were getting no data in this. So there's no reason for us to debug this. It's fine. I'll remove the breakpoint. And then we have the result in the callback. So remember this SV task that we talked about, and I'll just wait for asynchronous processes again. So we run the process. The SV task here is 3. So I'll execute it. Now we have received the result from your head of first entry. We are appending it to this one. And mind you, this SP task, it was 3 when we were waiting for it. So now we are going to minus it. So we tell them, okay, the first instance of the parallel process is complete and SP task is to do F8. Again, now we have come to the second one and we are appending the, oh gosh, data into a sorted, because it's a sorted table, we cannot append it. So many issues. No worries. I'm just going to remove it for now because this is just taking too much time. What we will do is in the process method, I will not do this. Uh, in the callback, I will not do this. Cool. So run this again. So we received data from this. So this is your first. SV task is 3. Again, we received the data the second time. SV task is 2. And again, we receive it the third time. SV task is now 0. So we had to wait until SV task was 0. So now this means that all the tasks have been completed successfully, and now we can move ahead. So in this case, obviously, because we were getting dumped previously, because this is a sorted table, I need to find different table type for this one, or adjust it, adjust the syntax. So we will not get the dump. That's why I've removed this condition for now. But in so now, like, the parallel processing itself is completed, and then you are free to do any other logic on your now cumulative data that you had. So that's it. So it's pretty straightforward, pretty simple. You just have to create an RFC function module like so. And then don't forget you're starting new task. Remember the task type is C-like. And then this is the destination group. And don't forget your calling function on end of task, because this is optional. There's a chance that we might forget this. That is all. So thank you very much for watching. Hope you have a very lovely day. And if you like this course, please subscribe to the channel. Thank you.